This is Lesson 7 in our Calculus 3 series, Cylinders. Before we talk about the definition of a cylinder, I'd like to start with some examples. In Lesson 1, we had this example, x squared plus y squared is equal to 1, and we took that sketch in 3 dimensions and recognized that it's a cylinder. We started by sketching x squared plus y squared equals 1 in the xy plane, and then we realized with this equation we have no restriction on z could take any value, and we shifted this circle up and down for any value of z. And so we get this cylinder here. And this is the standard shape that we think of when we say cylinder. But the geometric definition of cylinder is a little bit more broad. So let's take a look at a couple more examples that also fall under the definition of cylinder. Let's talk about a parabolic cylinder. So far we're looking at just a parabola, z equals y squared, in the zy plane. But remember, this equation is now in 3-dimensional space, and we recognize that x has no restrictions with this equation, and so x could take any value. So that means we can have this same parabola shifted forward and shifted back along the x-axis. Now let's try to visualize this as a surface in 3-dimensional space. And that's our parabolic cylinder. Let's take a look at one more example before we talk about the definition of cylinder. Z equals cosine x. We're starting with just the curve z equals cosine x in the xz plane. But we notice that this is an equation in only z and x, so y could take any value. So we want to take this cosine curve and we want to bring it along in the y direction. Shift it to the right and shift it to the left. And look at the surface that gives us. And this is our surface given by z equals cosine x in 3-dimensional space. Now let's take a look at the definition of cylinder. A cylinder is a surface that consists of all lines that are parallel to a given line and that pass through a plane curve. So let's take a look at this definition with the sketches that we have already. It's a surface that consists of all lines that are parallel to a given line. Well, all the lines that we've drawn in here are all parallel to the y-axis. They're all parallel to the same given line, the y-axis, and that pass through a plane curve. A plane curve is a curve in a 2-dimensional plane. So the plane curve that we're talking about is z equals cosine x here in the xz 2-dimensional plane. So in fact, this surface does satisfy this definition. Let's take a look at the one we had before. Again, we're looking for all lines that are parallel to a given line, all lines that are parallel to a given line. All of these lines that we've got on our surface, they're parallel to the x-axis. And these lines have to go through a given plane curve. Well, they all go through the original z equals y squared in the yz plane. And let's go back up to our original example of what we normally think of as a cylinder. And let's see where those lines are. Now we've sketched in the lines that are all parallel to the z-axis and that all go through the plane curve x squared plus y squared is equal to 1 in the xy plane. Now you might notice in each of these examples that we're missing one of the variables in the equation that we're using, right? This is 3-dimensional space. Typically we would have an x, y, and a z in our equations. But here we only have x and y. Here we only have y and z. Here we only have x and z. These are the simplest kinds of cylinders. When one of your variables is not in the equation, notice that's the axis in which all the lines are parallel to. Here, y is not in our equation, but all the lines are parallel to the y-axis. Here, x is not in the equation, and all the lines are parallel to the x-axis. And z is not in this equation, and all of these lines are parallel to the z-axis. Now again, when we have an equation that only has 2 out of the 3 variables, those are the simplest kinds of cylinders, but they're not the only kind of cylinders. Because think about this parabolic cylinder. If I just rotated it a little bit, it still satisfies the definition of a cylinder. It's just that we can't easily describe the lines that we're talking about in the parallel direction. Same thing with our z equals cosine x here. Of course, the equation would change if we rotated it, but we could rotate this surface and it would still satisfy the definition of a cylinder, although it wouldn't be nearly as easy to describe. So we're going to stick to the simpler ones to describe for now. So you'll notice that the cylinders we're talking about will only have 2 of the 3 variables in their equation. And in that case, then, in the definition, we're talking about all the lines that are parallel to a given line, and that given line is going to be the axis for the variable that's not in the equation. And then the plane curve that we're talking about in the definition is the 2-dimensional sketch of the same equation. So again, here we had z equals cosine x. We first started with our sketch in the xz plane, and then we extended it in the y direction. So that original sketch that we had in the xz plane, that's the plane curve that we're talking about in the definition. Now let's take a look at a couple more examples. Here we have z equals x to the third. So again, we're starting in our xz plane. We're starting with this curve in our xz plane, and then we're moving it in the y direction, right and left. Once we have those copies of z equals x to the third in the different y planes, then we can connect them with our lines that are parallel to the y-axis. And this is our surface z equals x to the third. Now let's take a look at y squared plus z squared equals 4. So again, we're starting in just the plane that contains this curve, so this is the yz plane here. And we sketch the original circle of radius 2 in the yz plane. And then we're bringing it forward and back in the x direction. And once we have the copies of those circles, then we connect them with the lines that are parallel to the x-axis. And this is our surface y squared plus z squared equals 4. And right now we're really just introducing these surfaces. And I made a point to draw these all by hand so that you can learn how to sketch them as well. And we'll conclude our lesson on cylinders here.